Hello, welcome to the Maxi course of the mathematical writing. The first order of business, we've transcribed the enrollment forms that you filled out, and these might have typos, so I'm going to circulate this sheet around the room. When it comes to you, just take a look and see. You don't have to read everybody else's, but look at your own and make corrections on it, please. And if you should be on here and aren't, why not just make a note on this sheet instead of doing it on the enrollment form, okay? So, see, can we get this on TV so you know what it looks like? Looks like this, okay? Several pages worth. So, please correct this as we hand it around. Thanks. Now, let's see. Old business, I just brought a few things with me to show you. First of all, I had forgotten the other day to bring this book with me. How to Write Mathematics, published by the American Math Society. I believe you can certainly get it from the society, and it should be possible to order it through the bookstore. And Max Schiffer here, the third author, is a emeritus Stanford professor who contributed. And Paul Helmich's article is the one that I thought had the best humor in it. And so anyway, I wanted to show this one. His collected works? What, in his books? Well, no, I'm not sure. He's written so much. This article originally appeared in let's see, wait a minute, Steenrod. This article originally appeared in a French publication here, Leçon. I think this, Marianne, what does this mean? Teaching? Okay. Teaching of Mathematics, okay, 1970, and then it's reprinted in this thing, and a more honest title would be How I Write Mathematics, and so on and so on. And but I'm not sure. It might very well be reprinted. Has several points like write good English. Honesty is the best policy. Down with the irrelevant and the trivial, and so on. Okay, so he's got. Do and do not repeat, all these, the editorial we is not all bad, use technical terms correctly, use symbols correctly, etc. All communication is exposition. That's his neat article in there. And I wouldn't be surprised if it was reprinted because it's one of the best available, if not the best, on the subject. Then I said something about using mathematics in titles of articles, and over the past few days I ran into what might be the record for the abuse of this rule, and it was all started by Gauss, actually, who's probably the greatest mathematician who ever lived, and he wrote this paper here. In Latin about the infinite series, and then he mentions the infinite series in his title, Part 1. They never did publish Part 2, but anyway, this came out in 1812, and so then somebody else writes an article in a journal a few years later, and here we have the same thing with two displayed formulas in the title. So in other words, not only mathematics in the title, which is hard enough on all reviewing and information retrieval systems, but here he has displayed formulas in the title, and so this is on the case when the series of the form y equals etc., a square of the form such and such has, and this is a famous. Nice little paper, and then when Kummer wrote a few years later, he had to do the same thing, So putting this, following Gauss's tradition, I think it stopped about there. But now, what happens when you have to put this into the bibliography of a book, of a paper? So I happen to be writing a book now that refers to these articles, and so when I got to Clausen, so here I had to put it in. Now, there you go. Okay. And let's see, where Gauss gets in there. Now I couldn't, there wasn't room on the line for his formula, as it turned out. He wrote too many of the things. But really, when you give a bibliography, you ought to you ought to quote the original title in full. Although I did look up these references in other bibliographies, and they usually put a few more dots in the formulas than the original authors did.
One of those references you had the Chebyshev there spelled in Russian, and then in parentheses you had...
Yeah, right. No, this is spelled in French. This isn't Russian. Russian is Cyrillic alphabet, and in French, if you wrote it this way, it would be pronounced che instead of che. And so they put a T in front. In other words, there's different transliteration schemes from Cyrillic, depending on what language you speak. And for example, in German, you would use a W to translate a V sound. But in English, and a lot of times people will use the Polish scheme, where a C really means a TS sound. And this means that, and so I've adopted the Library of Congress scheme for transliteration when I refer to a Russian person, and I have to be consistent. This meant that Tchaikovsky had to be listed under C, although he's almost always given with a T because of the French tradition. And Chebyshev, there's at least 30 ways to spell Chebyshev, I think, but I didn't use the Cyrillic alphabet here, and I didn't use. I referred to a Chinese work. I didn't use Chinese characters here. I didn't take the time to metafont those symbols. Now, another comment I could make about the bibliography here is that I think it was Mary Claire's recommendation to spell out the titles of things instead of using abbreviations. This will make the book maybe 2 pages longer, and it might add a few cents to the cost of the book. But only 2 pages out of 500, that's trivial. And it's much. I mean, the purpose of the bibliography is really to encourage people to find these things in a library. They're a wonderful thing. Not to impress people by the length of your bibliography, but this helps too if you want to impress by the length of it. But the main thing is to make it helpful so that people can find things there. And so like Journal de Math, now a lot of times people will JD Math, and then they won't know that, or sometimes they'll call it Louville's Journal, which it was also known as because he was the editor. There's this one here is Journal für die reine und angewandte Mathematik. This is really the first great mathematics journal in history, and this is volume 3 when he published it here. But this one is often called Journal für Math, and so you're looking it up, and you have to know that convention if you don't happen to realize it. And every journal has its own. Now this is a question about capitalization. This is the way they capitalize it on the title page, and they use upper and lower case, and this is what they do. You can probably see that. No, actually, in the bottom of this page, it's still called Krell's Journal. Krell is the editor, but on the title page, that's what he called it. And this is we can start capitalizing things too, but I tended to stick with the older conventions when I'm dealing with the older journals. Now here, for example, Royal was capitalized, I believe, in the Journal of the and they keep changing the title of that journal depending on whether there's a king in France at the time or not, But what was the other examples? The old Russian Academy tended to do things. Only a few words would be capitalized. So I tried to. But anyway, the main thing was to try to in your titles to be consistent with what the authors do. I'm even going so far as to try to spell. If the name is given in full, I give the full name. If it's not, if it's abbreviated, I give just the abbreviation of the name that the author used at the time. I don't know.
Weird typographical conventions
like what? Like Oh, here, yeah. Well, this here. In fact, I had to slant this logo here. That was pretty tricky. Yeah, but right. And here I couldn't. I still haven't been able to find this journal. So but they didn't capitalize the R there, as far as I know, in Berlin. And so, but I haven't got the page numbers anyway. The main idea, though, in a bibliography is to be helpful and not to be. And you can go on and overdo it in many ways. Maybe I have here. I don't think so. But people would give the like Mary Claire says. Usually, like when I say Addison Wesley, I don't have to say Reading, Massachusetts, where they're located, because it's a well-known publisher. But on the other hand, sometimes there are some publishers that are so unknown you'd like to give their address and telephone number in order to do it well. Okay, we'll talk more about that later if there are questions on that. But now the main thing I wanted to do today was to go through the homeworks that were turned in. I checked those, and there were quite a few points of interest that can, just to sort of, what do we call it, lock up what we talked about on the first 3 days. And then there are a few points that came up that I didn't have in my notes. Oh, two other very quick things. I do have the other articles I referred to, the manual for monthly authors, and this article about making math intelligible. These are in the library. You can get them by asking at the desk. There's some Xeroxes of this were made for your convenience. Okay. Now these homeworks are anonymous. I don't plan to turn them back, but or to give letter grades on them and so on. It was just for practice, and the main thing I'm a firm believer in learning by not being afraid to make mistakes, but just by doing and then taking a look and seeing what could be possibly done better afterwards. So I don't reveal the names of the people who did these, but we will put them on the screen, and just to show some of the things that I think are interesting about them as I scan through them. In 2 or 3 cases, unfortunately, the person who had this assignment didn't really understand the concept of a mathematical proof, and so there were mathematical errors in it. Now, that's a shame, because I think they know that the high schools aren't doing the job they used to in teaching how to prove things and so on in mathematics, and it's certainly, if you're going to really be writing expositions of mathematics, you should understand some of you should understand the principles of what really constitutes a rigorous proof, and these words aren't just random, but they do have to go into certain patterns that satisfy logic. On the other hand, I assume that that's not the purpose of this course. Is not to teach how to make proofs. The purpose of this course is to talk about writing, assuming that you already know about proofs. And these people presumably they had to do the assignment that I gave them, even though it wasn't one that they would ever really want to write about. But if you are a computer science student who wants to be successful, you really ought to know about mathematical proofs. I think it's pretty hard to go through life without it as a good computer scientist. Now let me just show you a couple of those little errors. Here was a okay. This one is a little hard to read here. Anybody remember this problem? It says, since P is not in A sub n, it must be the case. Where are we here? The case that P sub I less than P sub j for any I less than j. And here, that is not for any I less than j. That's for some I less than j. There's quite a difference. In other words, if you violate 3 conditions, that doesn't mean that all 3 have been violated. It means that at least that one of those conditions is true. So it's not. Things that aren't in this set of non-increasing vectors aren't increasing vectors. They're just not non-increasing, and we'll get more of that. Anyway, that's one of the things came out. Since we can't read that one anymore, let me try another one here. Okay, I've got a point here. In this case, L of C and P equals C, where C is any element of capital C. Now that's just not correct. There's no equation that says that the L of C and P equals C. In fact, this was you look at the sentence here. Let us assume for the moment that P contains the null vector 0 as an element. Let us further assume that it is computed by letting P sub j equal 0 for 1 less than or equal j less than m in formula 2. Let, in this case, L of C and P equals C. Whereas C is any element of C. Now, that word any again is confusing, but that's just, first of all, there's no reason why you could possibly assume that it contains the null vector, and you're supposed to, the real reason is, in the mathematics here, was that you can let m equal 0 in the definition, and then that shows that L of C and P concludes it. So anyway, this just indicates really a lack of fluency in mathematics, and if this were correct mathematics, then the writing is something that we'll talk about later. But that's the main thing. Is this the subject of the course will be writing, and occasionally we'll have to use some of the idioms of mathematical proofs in order to make our points. But the similar things would go for any kind of mathematical exposition. Okay, now let's look at this line that we just had here. The person had equation and then crossed it out and changed it to formula. That was not my correction. That was on the paper as it was given in. And you see what 2 is here. It is definitely not an equation. Well, it is an equation actually. Okay. So equation could be used there, but sometimes the thing that you display doesn't have an equal sign. It might have a less than sign or something. So it's hard to refer to something that says, n less than 5 as an equation. So calling it a formula or a relation or a statement or something like that is usually safer. But if it's an equation, you can certainly call it an equation. It's a definition. That's even better. Yeah. In definition too, and putting the 2 in parentheses is what I would usually do, but or in brackets as whatever this symbol is here.
How do you feel about just saying in parentheses 2?
In 2. If it's in parentheses, then I wouldn't mind that and dependent on how on the tempo that I was trying to set. Sometimes I want to be a little slower, sometimes I want to be a little faster, depending on the environment. Now, let's see. We know that L of CP is a subset of A sub n regardless of what C and P are, as long as, I put in this comma here. Now, commas to me are indicative of something that it's something that the reader isn't supposed to be aware of, but it's supposed to help the reader because it corresponds to a pause when you're doing it verbally, and this would also help you know what's coming up without looking ahead, and that's very important for comprehension. As I said the other day, there's this one pass. Don't go backwards to reparse the sentence aspect of things when we're writing. We try to have it so that a person can read it without look ahead. And the comma helps with this. We know that L of P is regardless of what C and P are, as long as C and P are both a subset of n to the n. Now this is an unusual error here, but C and P are both a subset of n sub n. I would say both subsets of n to the n. Anyway, okay. Now, here's an example of on the bottom here is an example of something we pointed out. Don't introduce subscripts unnecessarily. Assume that capital P contains only the element P sub v. Now, why not just say that it contains only the element P? We're introducing a new symbol. Why do we have to introduce a new symbol with a subscript at the same time? So And it doesn't have to contain only that element. It might just contain, that this element and many other elements. That's a mathematical error. But okay, now here we've got another thing. So P sub v, read P for that. But now he says Px less than Py for some x less than y. And then on the top of the next page, where Pv bracket r is the rth component of the n-dimensional vector P sub v. Now here I should say something about computer science notation versus mathematics notation. In programming languages, the component, the rth component of a vector is used. Pascal says use square brackets, and that's something that's easy for a computer to understand. A lot of people write paper. No, I didn't see it in any of these homework, but I've seen a lot of PhD theses where people will write an asterisk for every multiplication sign in their formulas, and they go through pages of derivations, and we got these extra asterisks in there as if this makes it really a multiplication. Now, when these high-level languages came out, ALGO had what it called a publication language as well as the language that you actually submit to the computer. And the publication language suggested using subscripts for indexes suppressing the times sign and things like that. That was never really very much followed in articles published in ALGO language, because people wanted it to be very easy to transliterate their programs. They never really wrote 10 to the n with a superscript, but they would write 10 whatever ALGO symbol was. They had different ones at different times for powers of 10, and so on. Now, that's okay if you're writing about a computer program that's going to be submitted to a computer, but when you're doing a mathematical proof, that just messes things up. It's a whole bunch of clutter. It's not really too bad to call PR the rth component of a vector, but most of the time it would be much nicer to have just said P sub r as in the original. Okay. Another point that this raises is, what about well, this is kind of awkward here because the notation is being introduced in steps. This means that something x and y are used, and then they explain what x and y are, and then they explain what the brackets are in terms of r, which is yet another local variable. R here is introduced just for this phrase. R is a dummy variable to refer to a general component, and so on. So that becomes somewhat awkward, but it raises a general question that I think is worth talking about, and that is, it is natural in exposition to hold off introducing some parts of your notation until after you've said them. Instead of, in other words, I like the first point here. Suppose we already knew the bracket notation. Then I would definitely say P of x less than P of y for some x less than y. Before instead of saying this means that for some x less than y, P of x less than P of y. It sounds much better. You get to the bottom line, even though you're explaining the bottom line in terms of undefined notation, because you get to the definition very quick. If this for some x less than y would come up in another sentence, a few lines down, then then the reader's hanging like, what's x and what's y, and so on. But it's much better to say set a sub I to 0 for all I, than to say for all I set a sub I to 0. It's so much more punch if you can say first what you're doing and then say set a sub I to 0. Well, the person doesn't really know what I is, but right away you told him for all I, and so then you got that through. So now I had some arguments with people on the comprehensive committee last year about certain wording of certain questions where they thought that it was hanging too much to go by. But I do feel that effective communication often puts the action before the definition if the definition follows real quick. Now here it gets carried too far, though, I think, because first we have to define x and y, then we have to define the notation, and then that notation includes an r, where r is sort of informally defined. So you have to break that into two parts and do it in two steps. There was a computer language called ISWIM, which stands for If You See What I Mean. that was all based on this where notation, putting declarations after, and it actually looked very good in small examples, and then on large examples it was a total disaster. Okay. All right. Now but by the way, those of you realize that I'm picking out mostly the errors that I find in here, and I'm not going to exclaim about, oh, this was good. So in general, I was fairly pleased with the assignments that I got, but I'm trying to. But you learn more by doing something that's not that can be improved, and so I'm going to be focusing on that when I bring these up here. Okay. Well, now here the very first, I say the first sentence should be your best sentence, right? And right away, here we got two formulas without anything in between them. I think, wasn't that Rule 1 or something in the notes or something like that? So observe that by the definition of LC and P, comma, C. Now, it's just sometimes this is going to be confused as a single phrase. Now, mathematicians do that an awful lot. If you look in journals, you find that rule violated a terrific amount. And if I were, so I would instruct the typesetter to put an extra space after this comma here, and I would train them to put a quad after every comma for these poor mathematicians that don't know Rule 1. On the other hand, I would maybe it would be better to bring it right up next to the comma and then ask the mathematician to correct it on galley proof by putting a word in there, so that they would learn the problem. So anyway. We have to reformulate this somehow so that we don't have two symbols right smack in a row. Now, here was another interesting thing. It says, now assume for a contradiction that L of C and P contained in A sub n. Now, that's a peculiar phrase, but it's not quite. I haven't heard it before, and it doesn't sound right. But it's sort of we're getting at what we're getting at the point of we're going to do a proof by contradiction, but this phrase doesn't seem to be a very good one. We'll see good ones as we come along later. But this is now assumed for a contradiction. This is something I haven't got a word for exactly what's wrong there. That there is a P such that P not an A sub n. By the definition of A sub n, there exists ij such that Pi less than j, where P is this vector. Now here, there's a question as to whether or not when to introduce the notation. What does P sub I mean? What does P sub j mean? I raise it here not to suggest that I have a definite solution, but that it's not. It's something. It seems that it doesn't quite work very great flow here. But if I give P with all its subscripts up there, there's a danger that I'm losing the thread of the argument by making this sentence too complicated. On the other hand, then there's also a danger that I don't know what P and J are, even though I have the where coming up rather closely here, because that's not the point of this construction. It's the existence. This such that is terrible. It should and exist. Goodness, I said don't use those symbols, didn't I? When you use 3 dots, there should be a comma in there to complete the darn thing. But in general,
actually, how do you like an ellipsis punctuated? Do you want
ellipses?
comma,
Yeah,
dot, comma?
yeah. Ellipses. We talk a little bit about ellipses. The other things, the other books mention this too, and I didn't say very much about it. Now, the modern convention is settling down to one that I think is very nice, but it's gone through different transitions. At one time, people used only ellipses that were up high, and other time they used only ellipses that were down on the line. And now there's a general convention that I think works well, and that is to use 3 dots down on the line in a case like this in a comma context or in a multiplicative context. So if you're multiplying the things together, you would also put the ellipses down in the bottom. But if it's in a semicolon type of context, that's down on the line. But three dots that are between greater than or equal signs would be raised like that. See, that's done well there. But here's three dots down on the line, and these are three dots up on the line. So if it's in a context of plus signs or relations, raise them. If it's in the context of comma, here's a plus sign context, you see. And repeat the operator before and after the dots. You have a comment?
Is there a space after that third dot?
After which, this here? Here?
Down.
This one?
No, the third one. No, you were on the equation.
This one. Now what about this one?
No, the dots, the ellipses.
Yeah.
Is there a space after that third one?
Well, there's a space around a relation usually.
Because dot, space.
Oh, well, okay. Now these dots are not. If you write on if you would typeset three dots, you'd find that dots are very narrow, and those dots, and so there's actually spaces to space them out. But now you're asking about this right here, at this point.
Right.
Oh, yeah. There's a space before and after those three dots. But that's not the space that goes with the dots. It's a space that's sort of before and after the greater than signs.
Well, the shape of the greater than makes it look like the spacing is uneven.
Yeah.
Oh, okay. I can't vouch for this typesetting system, but it might be. But it might be a. But it might be just a. I mean, look. Yeah, here you see there looks like more space there, but the one is a sort of a strange symbol, so you can't get it. But the convention is to. Yeah, the convention wouldn't be to insert an extra space there, but actually if it's followed by a right parenthesis, you would put a space there because otherwise it looks like it needs one. I don't know. There's all kinds of accidents happen in formulas about spacing, and there's rules that'll cover 95% of the cases or 99% maybe, but if you write a lot of mathematics, you're going to have this 1% is going to arise once in every 100 symbols or something, and that's once every couple of pages. So there'll be something where a little space fiddling will make a small improvement, and I would say that's second or third order correction. But you can there's certainly nothing against improving the thing afterward. The most common error is to have three dots and then another comma without enough space between here. I mean, it would be very. I think probably it's in this Macintosh system here, which probably does that. Well, I don't know. This is a little too close to the semicolon, I think. But there's worse cases here. You can see if you look in the book later. I don't know. Whoops, what? These dots are too far apart, though. It's not that what? Here, yeah. There's something, but it's because these are too far apart more than that. The other ones are okay. Well, okay, but that was something that certainly. Arises a lot. I mean, I guess von Neumann wrote a paper when he was young, where he was very proud of the fact that he didn't use three dots anywhere in that paper and so on. But I think it was hard to read than his other papers. Where am I now? Here's a. Since we're talking about typesetting, here's something I saw that somebody was using tech here, and in order to get the empty set symbol, used a some kind of a backspace thing. Okay, well now there is a symbol in tech called empty set, which solves this problem. Because the ordinary slash comes down below it's not centered. In order to really put over zero, you'd have to shift it up a little bit. And besides, then you get a symbol that looks too black because you got to take actually the empty set symbol is made from a zero that's thinner so that it doesn't and puts the thing on there. Some people use another thing for empty set that looks more like that, and tends to be confusing if you're also using the Greek letter phi. Well, this symbol is more distinctive, but that's a matter of typography of what fonts you have now. Here's another thing in TeX. If you were doing this, there's something in TeX called mid, which will put a vertical line in the middle of a set notation and will also leave space around it. As it stands here, this looks like a single symbol CC, but it's but more properly, if you had said mid, then you would the actual TeX construction would be, to get the brace you have to write a backslash brace, and you'd say C and you say mid, and then you would say C in capital C and close it. That was, I'm not going to make this a course in TeX, but there are aspects of typesetting that are covered in the TeX manual with examples of how to improve the spacing of formula. The thing I wanted to okay, now here's I want to point out a couple of good things here in this one. We demonstrate the second conclusion by contradiction. That's very nice. First, it tells the reader what's going on, that we're now going into the second conclusion, and we're going to have a proof by contradiction and so on. So it was a good transition sentence that started things out and kept everybody in sync. It uses present tense. We demonstrate, or not, we will demonstrate, so on, and we'll talk more about tenses later. It's okay, it's fine. There's different ways to do tenses.
Question?
Yes?
This is actually more typography, but the next sentence, P not an element of something, is broken.
Yeah, this is P
line break.
subset. Yeah, right.
But that's a line break in the middle of a formula, isn't that?
That's right. Bad? It's not too good. In fact, you had to pay a penalty of 500. I mean, in other words, it would have looked even worse without that for some reason. TeX didn't do this easily, now, of course, I would solve it by putting the word "that" right there. But as far as the break is concerned, it was, it's an unfortunate break, because you come all the way back here and it's kind of a letdown to see this little one symbol here, anticlimax for sure. So I would, but anyway. But I'm not sure about this "that." This seems to make it a little bit wordy in this particular case.
Well, it's definitely read the phrase after.
Yeah. And it spoils it, because we got a "that" right there. So there's already a "that." So that's not the solution. So in TeX, I would just write my formula. Then I put this in braces. I would say P not subset and so on. And the braces tell TeX, don't break this formula under any circumstances, and you'll stretch out the first line. And that isn't really, this is such a nice short phrase here, it doesn't seem to be necessary for me now, but I'm not sure why. Sometimes I want it, sometimes I don't. Here, I like this next sentence. There must be a witness to the unsortedness of elements of P. This is again helping the reader understand what we're doing, and the witness is a sort of a buzzword now in certain branches of computer science theory, but still it's nice to bring in vocabulary sometimes, I think. But now, do you see a problem here? Some vector P in P with two elements P, I, and J, such that among the... No, well, mainly, yeah, but mainly everything is elements. This is my main thing. He's got elements of capital P and he's got elements of vector P. And so I think it'd be helpful to distinguish by calling these components. Okay. Then elements come in here again, but then here it's components of L. Okay. And so it's better to have two words instead of having elements all over the place. Let's see. I less than J, but Pi less than Pj. Oh, I don't know what's wrong with that. Let's see. Well, I don't. Here's another thing about that in the last sentence here, or the last paragraph. We have shown then that at least one element of L of C and P, namely that, given by C plus Kp as above. Now namely is usually used to sort of say, in other words, and so when we have that, we'll tend to think it's going to be parallelism with what we have shown. So we have shown then that, but now, we're using that here. It's that given by. In other words, here I would say the element or something like that. Namely the element given. So, I have to figure out where the namely is coming back to. So namely the element given by, because it's saying namely that where are we showing something else? It seems to me going on. But this is so that a person again can read it in one pass. When you see this that you don't know, you got the wrong prediction of the future.
Usually when you're using namely, you're saying that.
Please push the button.
Semicolon.
No, I don't think so. We'll have more examples of namely as we go on. Here's a homework assignment that I wanted to mention. Numbered everything. Now maybe that was the word processor did that, but every single display was numbered. I don't think that's that's a wise idea. You're losing some of the effectiveness, and you're going to be up in the thousands by the time you get to the end of the chapter. The word non-empty was given with a hyphen here, and non-negative with a hyphen there. And as I said the other day, these hyphens are tending to be dropped these days. Some books will still use them, but I think the hyphen in these words disappeared about late 60s and something like that. On a word processor, unfortunately, you have only one symbol for both a hyphen and a minus sign, and it's usually too long for a hyphen and too short for a minus sign, but gotta live with it. The parenthesis here, this is copied from what was in what was given, but it's really not necessary to have a parenthesis around it, and it makes the formula unnecessarily complicated. So I would leave off those parentheses. In fact, that meant here that somehow it seemed that they, after subtracting 1 from K, still had parentheses around the Ci minus Cj, which was not necessary, and so those parentheses seem to be leading to clutter. Here's a use of the word I, and I see that Mary Claire sort of defends the use of I in technical writing instead of saying we in her book, and I guess we'll have to disagree about that one, because maybe it's not really bad, but I think in a lot of cases the reader isn't going to be that interested in the person who's presenting it, but is more interested in the cooperative work of working together to prove the result instead of being impressed by how the author proved it.
Question on that?
Yeah.
You said in your pointers that we means you, the reader, and me, the author.
Yeah.
What if there's more than one author, and you
Yeah.
don't mean you, the reader, and me, the author? You mean just me, the author?
Well, then you get the great luxury of being able to use it ambiguously, and so you can let them think anything they want. No, I don't know. I would still prefer the teamwork aspect of it. I think of when I read a paper, I also recommend the same thing for reading, and that is imagine that you put yourself in the mind of the author, or you try to solve it before you see what the solution is, but you're thinking about how to solve the problem, and then when you get the solution, it's really something that sort of was partly your contribution too, as well as the author's. I don't know.
Well, there are situations where that's just not appropriate, that you can't expect the reader to participate you at all. You're just giving definitions or something.
I know. So then you have to add extra clauses to make it unambiguous. And now, the Chinese language is so much nicer than English in this way, because in Chinese most of the words are neutral in the first place, and you only add qualifier. You don't have feminine and masculine. You don't have plural and singular. You just add that on if it matters. And if we had a language like that, then we would be then we could do these things. But still, when we have it, we can use the same idea. So it shouldn't, So in the case where we do have the chance to use it ambiguously, then we can always add another phrase to disambiguate it when it matters, the way they do in China.
Question.
Yeah.
What about something like the author or the authors?
Yeah. Yes, the author. Well, this is formal, but it can be done well. It would be. I would say, for example, if you're writing a paper with two authors and one of them proved something earlier or something like this, you might say. One of the author's paren initials, or you would say the first author or something like this. I would hesitate to say the senior author, only at Harvard, Another comment on this one. Let C and 7B C1. Okay, now here you see this is what happens when you put three dots very close together and there's no comments. But that's not what I wanted to get in here. I wanted to say I would insert the word let here. Let C and 7 be this and K be this. In other words, and let K. I just would, it's not strictly speaking necessary, but it sure helps to repeat the word there and make the parsing of the sentence clear. There's a typo here. This coverting. This is something about the CIA. But we don't, that's just a typo. Now, the word "got" is something that raises hackles in all high school writing classes, and it's a word it's a good past tense of get and so on. But why should we use past tense? We have to think about tenses but I think here it's reached. If it was past tense, we would still use the word reached or something like this, and I would probably say have reached. Passive. What is it called? Past perfect tense. Oh well. I would put a colon there and so on, but the word got is definitely a losing one in that place. Okay.
Don?
Yeah.
Why not just stick to the present tense for
Everything?
almost all writing?
Yeah. It's something that you can there's two ways to go, and either one is defensible, but you should stick with one you have. And like I discussed this once with ACM editorial office. They said our copy editors like to keep the present tense everywhere. On the other hand, if you get a longer article, you really can, it makes sense to distinguish between something that's going to occur in a later section and something in an earlier section, and say, we saw this before and we will see something else. And makes a lot of sense to think of the paper also being read sequentially. So it turns out, so I tend to think in a shorter paper I get by with present tense, but it's hard sometimes to have the same effectiveness of the past. Now I'm a believer in using the language the way it was for the things that it evolved to serve, and language has these tenses in it, and so how many how many handcuffs should we wear, or shouldn't we allow ourselves to use the things in the other things in the language? And so we're, I'm saying maybe you shouldn't say I, but we is okay. But I is also very good in any paper where there's a reason for the author to be of concern to the reader. And maybe any paper is that way, but maybe not. Maybe the material in the paper is more interesting than the persona of the author. So having tenses can be a help, but if you find that you've got many tenses going on, then it can be more confusing than helpful. Same with any good tool. You can overdo it. Typography, you can use 20 fonts and so on. It's much better to use one font then. But sometimes using bold, italic, and so on is a help. Carrying it to extremes, no. I see I've run out of time already. I thought I was going to get through this whole pile of papers. Well, Friday we'll finish them. I think there's a lot of other interesting things in there.